Hello and welcome to Mr. Thompson's Math Tutorials. I'm Mr. Thompson, and today we're going to be looking at simultaneous equations. Now, I got this question from Engage in New York, and I just modified it slightly. I changed some names and changed things from miles per hour to kilometers per hour, but otherwise it's unchanged. So here's Jorge and Horace, and they're going on a road trip. So Jorge here is going on a road trip with Horace. Okay, so they're driving somewhere and they're driving at a constant speed. That's an important piece of information because that's going to help us model this later. Now, Jorge is a safer driver. He's driving at a smaller speed at 100 kilometers per hour, whereas Horace over here, he is not such a safe driver. He's a little more reckless, and he is going 150 kilometers per hour through the whole trip. Now, Jorge and Horace left from the same location, but Jorge left at 8 a.m. He's an early riser, and Horace obviously likes to sleep in, so he left at 11 a.m. Now, assuming that they take the same route, will Horace ever catch up with Jorge? And that's what we want to do. And if so, approximately when? Now, there's lots of ways we can solve this problem, but one of the ways is we could simply make a table. So I've got a table here for this problem, and I could just start putting in times, so for instance, and actually I probably need to add another row. So let's just, oops. Let me add another table. Okay, so I'm going to add another table, and I probably should have had 3 rows there. Would have helped out. Okay. So let me move this table down. Okay, so here we go. Let's just start with 8 a.m. So at 8 a.m., and let's say that this right here is, let me put their names. So here's their names. And this would be Horace, and this would be Jorge. Okay, at 8 a.m., and actually let me color code these a little more. So sorry about this. So let me see. This is their names. Okay, so we have, let's put Jorge up top and then Horace down below. Okay, and then we have 8 a.m., 9, 10, 11, 12, 13. So that would be 1 o'clock, right? And let's just assume. So at 8 a.m., well, Jorge's just left, so he's not going to have gone very far, so he'll have gone 0. But after an hour, he'll have gone 100 kilometers. And after 2 hours, right, this is from 8 to 10 is 2 hours, so he'll have gone 200 kilometers. He's going 100 kilometers per hour. After 3 hours, he'll have gone 300 kilometers. After 4 hours, he'll have gone 400 kilometers. After 5 hours, he'll have gone 500 kilometers. And that could go on. Now, Horace over here, remember he slept in, so he's not going anywhere at 8 or 9 or 10 or really 11. But at 12, he'll have gone 150 kilometers. And at 1, he'll have gone 300 kilometers. Now, if we just sort of continue this on, let's see what happens. So we know that Jorge at 2 o'clock, so this would be 14, will have gone 600 kilometers. And Horace will have gone 450 kilometers. At 3 o'clock, which would be 15, Jorge will have gone, let's see, 700 kilometers, and Horace will have gone, let's see, it would be 600 kilometers. Okay, sorry, my pen's jumping a little bit. I'm going to continue down here because I've run out of space on my chart, but let's see, it would be 15, so 16 at 4 o'clock. Jorge has gone 800 kilometers, and Horace would have gone, let's see, 750. You can actually see that Horace is getting closer. At the next time period, so 17, which would be 5 o'clock in the evening, Jorge will have gone 900 kilometers, and Horace will have gone, let's see, another 150, 900 kilometers. And you can see right there, they've met. Now, I can represent this not only with a table, but I can also represent this graphically. So here's a graph, and we can represent this sort of story with a graph. So the first thing I'm going to do is I'm going to draw a line. Okay, so here we go. Here's my y-axis right here. I'll stop about there. And I'm going to draw my x-axis just here. Okay, I'm going to label this. So let's call this 8 o'clock, and then 9, and then 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. And then let's make these kilometers. So I'm going to make this, I'm going to go up by 50. So let's see. I don't know if I'll have enough. Let's see. This will be 50, 100, 150, 200, 250, 300, 350, 400, 450, 500, 550, 600, 650, 700, 750, 800, 850, 900. Just barely can make it. So I'm actually going to go up by hundreds instead. So I'm gonna continue labeling this. So this is 0 down here, but this would be 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000, 1,100, 1,200, and I'll stop there. Okay, so I'll do horse in green, or I'll do Jorge in green and then horse in red. So we know that at 0, at 8 o'clock, they haven't gone anywhere. So, but at 9 o'clock, Jorge would have gone 100 kilometers. See, he's that red dot. And at 10 o'clock, it's 200, and then 300, 400. And so I'm making a line that's going up here like that. Okay. All right, so that would be the line that represents Jorge. So let me just draw a line between that. Okay, so here we go. This is the representation of Jorge's line. Okay. All right, let's do the same thing for Horace. Now, Horace didn't leave until 11, so he would be here. At 11, he's still at 0, but at noon, he's gone 150, so he'd be right in between there. And then at 1, he's at 300. And then at 2, he's at, let's see, right about there. And then at 3, he would be at 600, so he'd be here. And then at 16, he would be another 150 up, so there. And then at 17, he's going to be right there crossing. And then let's see, he'd be 1,050, he'd be there. And then he would be, let's see, 1,000, he'd be 1,200 here. Okay, and so we'll represent his line, and I think I might have messed up just a tad there. Should be more like there. Okay, so let's draw his line also. Okay, so I'm going to draw his line, and I will use black. So his line is going to follow these points right here up. Okay, and again, you can see that these cross right there. Okay, so at that point right there, which I'm drawing in blue, and we can see that that's at 900 kilometers. Okay, and at 17. Okay, now these are lines, and that's the great thing, because we can represent this information as an equation, right? So once we have that equation, we can represent it, and then we can figure out how to draw that. Okay, so one of the things we have to do is we have to come up with the equation of both of these lines. So now Jorge's is pretty easy. We know that Jorge's line is going to be represented. In fact, let me do this in Jorge's color, which is red. Jorge's line is going to be represented with y being equal to his rate of change, which is 100 kilometers per hour, and then he's crossing the y-axis at 0. Okay, so this is Jorge's line. Okay, so really we don't need this plus 0 because it doesn't matter, but that's Jorge right there. Okay, now Horace is a different story. Now we know Jorge's rate of change. We know his rate of change is 150, but what we don't know is this. We don't know what his y-intercept is. So whatever we're adding, the y-intercept. So we're missing that information. So what we need to do is we need to do a little substitution to figure that out. We know a couple of the points that he's crossed, and we're just going to substitute those into that equation, and that'll allow us to figure out the unknown y equation. So let's just pick one that we know pretty easy. Let's pick this right here. So we know that 11 at that point, which is actually not 11, it would be 1, 2, 3, 4. He's really crossing at that point right there, which is 4 away from our y-axis. Okay, and that would be 0. So we'll use that as our point. So that would be 4. I know it says 11 on there, but if we substitute in 11, it'll be a little bit weird, and 0. Okay, so we know that the x-coordinate is 4, and the y-coordinate is 0. So I'm going to do a substitution. I'm going to say 0 is equal to 150x, but we're going to replace the x with a 4, plus a nothing. Okay? So I need to solve. I'm solving for this missing bit right here. We'll maybe put a b in there. Okay? Well, what is 150 times 4? Well, 150 times 4 is 600. Okay? So this is 600 plus b, which tells us if we want to get the b alone on the left side of the equation, we subtract. Okay, and I'm going to subtract 600 from both sides, which is going to tell me that b is equal to negative 600. And now that gives me my y-intercept. Okay, now one of the things I can do is I can actually find these values by substituting into each other. Okay, and this is something that we're going to practice in the next unit or the next lesson.